What is neurofeedback in BCI communication? Imagine being able to teach your brain to communicate more clearly with a device just by understanding your own thoughts. That's what neurofeedback and brain-computer interface communication is all about. It's a way to help people control their brain signals better by giving them real-time feedback. This feedback shows how active their brain is, often through sounds or visuals. When you see or hear this, you can learn to change your mental state to produce better signals for the device to understand. In brain-computer interfaces, or BCIs, sensors pick up electrical signals from the brain. These signals are then processed to find patterns that match what the person wants to do, like moving a cursor or typing words. Neurofeedback adds a layer by showing the user how well their brain is doing in real time. This helps them learn to produce stronger or more consistent signals. Over time, this training makes controlling the BCI easier and more accurate. The process starts with sensors placed on the scalp, usually using electroencephalography or EEG. These sensors detect brain activity related to the user's intentions or mental states. The signals are then processed to find specific features that can be turned into commands. The user gets immediate feedback, like a visual bar or a sound, that reflects their brain activity. If the signals are clear and strong, the feedback shows a positive change. If not, the user can try different mental strategies to improve their signals. This loop of sensing, processing, and feedback helps the brain learn to control its signals better. It uses the brain's natural ability to change and adapt, called plasticity. As users practice, they get better at producing signals that the BCI can interpret accurately. This makes communication faster and more reliable, especially for people with severe motor disabilities like amyotrophic lateral sclerosis or locked-in syndrome. Neurofeedback can also be used to help people improve focus, attention, or emotional regulation. By training the brain to produce specific activity patterns, users can enhance their interaction with BCI devices. This kind of training can take from a few minutes to several sessions, depending on the goal. The cost of neurofeedback systems varies but typically ranges from a few $1,000s for basic setups to over $10,000 for advanced equipment. Sessions usually last about 30 minutes to an hour and are guided by trained specialists. In essence, neurofeedback in brain-computer interface communication is like giving your brain a mirror that shows how it's doing in real time. It helps users learn to control their brain signals more effectively, making BCI communication smoother and more natural. This technology is opening new doors for people who need alternative ways to communicate and interact with the world around them.